Alright, today we're working on section 10.7, similar and congruent figures. Similar figures are figures with the same shape but not the same size. Okay? Congruent figures, they would be the exact same. Okay? They would be identical to each other. Congruent figures have all the same. They're the same shape, same size, everything. But those similar figures, again, they're the same shape, but not the same size. Okay? And triangles you have to be careful with. Keep in mind, just because if one happened to be, sorry about that, if one of them happens to be a right triangle, and one be an obtuse triangle, they are not considered similar, okay, just because they're a triangle. They have to have the same angles that we're looking at, okay? So that would definitely be something else you need to think about. They have to have the same identical angles, just smaller in size or larger if you're going in the other direction. Corresponding sides, those are the sides of similar figures that match. Corresponding angles are the angles of similar figures that match. What I want you to do is go ahead and hit pause and copy this information down, and I'll discuss it a little bit further. So corresponding angles would be angle A and angle X. Corresponding angle for B would be Y. And corresponding angle for C would be Z. Now when we're looking at corresponding sides, okay, corresponding sides would be segment AB is corresponding with segment XY, and you can see the blue sides are what correspond. Segment BC, which is the red, corresponds with segment YZ. And the green segments correspond, and that is AC and XZ. Okay. It says because these are similar figures, their sides are proportional, meaning that the corresponding sides will have a constant ratio. Okay. Corresponding angles are congruent. Now, constant ratio. Okay. It says what is the constant ratio for this set of triangles? Okay, well, the corresponding or consistent ratio is when we go from one triangle to the other. So let's write them as a fraction. So I'm going to start with AB with the blue, and I'm going from a 6 to a 2. So I'm going to literally write 6 over 2, which reduces 2 by dividing them both by 2 to 3 over 1. That's a 3-to-1 ratio. Remember, if we do this on the next one for BC and YZ, we have to start, since we started with this triangle going to this triangle, we have to start with that as well. So 9 to 3, so 9 over 3, which reduces by 3 for each one, giving me the same ratio of 3-to-1. And then the next one would be 12 over 4, which again reducing by 4. Which is going to give me 3 over 1. You're just simply finding the greatest common factor and reducing them so that they are over the same ratio, keeping them the same. We're not going to make this a 3. You could. Okay, 6 divided by 2 is 3, 9 divided by 3 is 3, and 12 divided by 4 is 3. It's the same thing, but we like to keep them in a ratio still. Okay, in a fraction form. So since they are all 3-to-1 ratio, that therefore it is considered similar in this situation. Okay. Now let's look at this one. It says if triangle ABC is similar to triangle EFD, find the length of AC. We've got to find the length of this. Okay, so how are we going to do that? Well, we have to find a constant ratio for that and see what the other ones are to make it similar. So it's a matter of simply saying, all right, what do we have that is similar? And this is flipped around, so we have to be very, very careful with this. We are looking at the hypotenuse, so we're going to look at the hypotenuse on this, which is we're going to go from, you can go from either one. We'll start over here and go 5 to 35, which is going to reduce to 1/7. And then we're going to go from this bottom line, which is going to be this one, is going to correspond with this. Okay, and it's a matter of trying to turn this way. If we take this and rotate it around or rotate it this way, you can flip your paper sometimes to see what corresponds with what. So if we were to turn this, let's see, it's going to look like this. So it's the same as this triangle over here. So if we turn that, this right here is going to, let's see, I've got to think about this myself. Okay, so this is going to flip, and when it does, you're going to see that this is going to be the bottom. Okay, when we flip this over, that's going to be the bottom. So that's going to relate to my 3 and the 28. So 3 over 28. I'm sorry, I've got that incorrect. Something's not matching up here. Let me pause this and double check. Alright, I see what the issue was. I knew something wasn't matching up correctly. So I'm going to erase this. This is going to be 28 feet over here. So when we flip this, let me erase this part as well, because this is not correct. Otherwise, it wouldn't be similar. So what's going to match up when I flip this over? My 4 and the 28 are going to match up. So 4 28ths, which again will be 1/7 when we divide both of them by 4. And then we are trying to find, going from the 3 to find this particular angle here, which is the bottom. So since that's the case, we are going to be 3 over what will equal 1/7. So that's my x. That's what we're trying to find. Okay, so if we go, there's two different ways you can solve it algebraically, doing cross multiplying, or you can simply say 1 times 3 is 3. So 7 times 3 is going to give me 21. So 3 over 21. So the value of x, this right here, is going to be 21 feet. That is going to give me that similar, and this again is AB, not AC. Okay, sorry about all that confusion. So again, a recap. Basically, you have to find the corresponding sides, and when you find those corresponding sides, you should have those other two will be equivalent ratios. Okay, so reduce them to simplest form, and then write that. Then you're finding the whatever it is. If you're starting with this number, we know if starting with this triangle first, since that's the top, that's going to be my top over x, because that's what we're trying to find. And then you're going to simply then solve them algebraically, or you can use just proportionals, saying 1 times what gives me 3, which was 3, and multiply it that way. If you did do cross multiplying, then it would have been x times 1, which is x, equals 3 times 7 is 21. And that'd simply give you that answer by cross multiplying. Okay, so a couple different ways of doing that. For this, it says which triangle is similar to triangle DEF. Assume corresponding angles are congruent. So I'm going to let you hit pause, and you are trying to find, this is the one that you're starting with. Okay, that's what you're comparing it to. Triangle number 1, number 2, or number 3. Which one of those, or which of those, meaning it could be all 3, it could be 1, it could be 2, or all 3 of them being similar. So go ahead and hit pause and you can do that. All right, well, this first one, trying to find the corresponding ratios or sides to get the ratios. We're going to start here. We're going to go 5 to this corresponding side, which is 6. So 5 over 6, that is in simplest form. And then we're going to go from 12, and the 8 would correspond. So there's 12/8. And right away, since this is an improper fraction, and this is a proper fraction, we know right away this would not be similar. So that one is out. So let's start with this, and we'll say 4 to 8. So 4 over 8, which is 1/2. Then we're going to go 3 to 6. So we'll go 3 over 6, which also equals 1/2. And so now we know that it would be congruent according to, or similar according to, those two angles, okay, that are given. Okay. So this one is a yes. And let's look at this one. And now we are going, let's say, we can go 8 to 12. So 8/12, we're going to reduce that by 4 to give me 2/3. And then we're going to go from 6 to 9. So 6 and 9, we're going to reduce that by 3 again and get 2/3. And since both of them equal 2/3, therefore they are going to be similar. Now the difference is, this one's an easy one because you can see that it doubles. 4 to 8, 3 to 6, it's going up by doubling it. That's an easy one. This one, since it's not as easily clarified, if you're trying to find a difference, from 12 to 8 is 4 and 9 to 6 is 3. Just because they're different, it doesn't matter. You've got to look at the ratio itself. So please be very, very careful with that. Many students miss this particular problem, number 3 here, because they see that the difference is not the same. It's the ratio that we are looking at. Okay, so there you go. If you have any questions, please write them down, and we will discuss it further tomorrow. Have a great day.